Now calculation involving unit cell dimension. The other name is density. Density of unit cell. Now how to calculate the density of unit cell? We know the formula of density. Density is equal to mass upon volume. Here M is the mass of unit cell and V is the volume of a cube. Okay. Suppose side length of cube is A. So volume of cube is A cube. Okay, now we find the volume. Now it's time to find the mass of unit cell. Mass of unit cell. Okay, so here mass of unit cell is equal to number of atoms in unit cell into mass of each atom. Means this is a given mass. Okay, given mass. Simply you can write Z into m, small m. Okay, so how to find out the given mass? We know that given mass is equal to molar mass upon number of particles. Here Avogadro number. Okay, number of moles. Okay, now here this is given mass and this is molar mass or atomic mass, and now this is Avogadro number. Okay, or Avogadro number, or you can say 1 mole. Okay, now put the formula of given mass into the mass of unit cell. So we get Z into molecular mass upon Avogadro number. Now put the mass value into the density. So we get density is equal to Z into m upon volume. Volume is how much? A cube. A cube into n A. Here Z atomic number of atom in a unit cell. Now I do the notation here. Wait. Now here Z number of atoms in unit cell, m molar mass or atomic mass. Here A side length or edge length. Okay, now here N is Avogadro number. Now what is the value of Avogadro number? Here 6.22 into 10 to the power 23 mole inverse is the value of Avogadro number, and this value is equal to the 1 mole. Okay, got it clear? Now this formula is really very important, because on the basis of this formula so many questions asked in the examination. Okay, till now is there any confusion or is there any problem? Then you can ask me. Now the next is, okay, I have a question. Isn't solid show any defect? मतलब क्या solid में defect होता है? आप इसी पिक्चर को देख लीजिए. भुट्टा, chrome, the arrangement of particles in a try to in a straight line, but they are in also in a straight line, but some of the particles forms a short order arrangement. This one. So what is this? This is a defect. Here you can see in this picture. So by this picture we can say that solids also have some defect. Yes, solid also have a defect. That's why solids are formed in different shapes. ओके, सो नाउ इसी के साथ हम स्टार्ट करते हैं अपने इम्परफेक्शन इन सॉलिड और डिफेक्ट इन सॉलिड. पहले हम बात करेंगे टाइप्स ऑफ डिफेक्ट की. यहाँ पर जो डिफेक्ट है उसको कैटेगराइज किया गया है. हियर द डिफेक्ट इज क्लासिफाइड इन फॉर्म्स. ओके, तो पहले डिफेक्ट होता क्या है? डिफेक्ट होता है द irregular arrangement, the irregularity in the arrangement of particles. Okay, now here defect is of two type. First is point defect, second is line defect. Okay, point defect and line defect. Here point defect we also called thermodynamic defect, and point defect is also called intrinsic defect. Okay, now here intrinsic defect, point defect and thermodynamic defect are also divided into three categories. First category, stoichiometric defect. Second is non-stoichiometric defects. Okay, now the third one is impurities defect. Okay, here stoichiometric defect or non-stoichiometric defect is further subdivided. Stoichiometric defect is also of two types: non-ionic solid and ionic solid defect. Okay, and here non-stoichiometric defect, metal axis defect and non-metal axis defect, or you can say metal deficient defect. Okay, now here non-ionic solid defect is also further divided into two segments. First is vacancy defect, and second is interstitial defect. And here ionic solid is also further divided into two parts: Frankel defect and second is short defect. Okay, and here in non-stoichiometric defect, the non-stoichiometric defect is also divided into two parts: metal axis defect and non-metal axis defect or metal deficient defect. Now here metal axis defect is also subcategorized into two parts: anionic and ionic vacancy defect, and this defect is called F center. And second is presence of extra cation. Presence of extra cation in industrial site. Okay. Now here metal deficient defect is also subdivided. Cation vacancies and extra anion occupying industrial site. Okay, here the defect is classified into two part, point defect and line defect. And point defect is called intrinsic defect and thermodynamic defect also. And here point defect is subdivided into three parts: stoichiometric defect, non-stoichiometric defect, and impurity defect. Here stoichiometric defect is also subdivided into two parts: ionic solid, non-ionic solid. And here non-stoichiometric defect is also subdivided into two parts: metal axis defect and non-metal axis defect or metal deficiency defect. And here non-ionic solid defect is also subcategorized into two parts: vacancy defect or industrial defect. And ionic solid defect is also subdivided into two parts: Frankel defect and Schottky defect. And here metal axis defect is also subdivided into two parts: first anionic vacancy defect, which is responsible for the F center, and presence of the second one is presence of extra cation in industrial site. Now here metal deficient defect is also subcategorized: first cationic vacancy, second extra anion occupying the industrial site. Now these all about the defect. Now the first is line defect. What is line defect? Line defect are the irregularities or deviation from arrangement in entire rows of lattice point. Here you can see in this picture, here the points are dislocalized in the edge. Okay, like that here. So due to the dislocation of the point, here the edged length is also dislocated, and this type of defect is called what? Line defect, as we previously seen in the picture. Now the point defect are the irregularities or deviation from arrangement in around a point or an atom in a crystalline substance. In point defect, we see the arrangement around the point in a crystalline substance.